Hello, I'm Maria Prodromo. I'm a researcher at the Eratosthenes Center of Excellence, and today I will present to you, and I will make a general presentation about the practical tools and technologies about the remote sensing. Just a moment. Γιατί μου δείχνει όμως εμένα? Sorry. It's okay. I'm gonna swipe. Это же мы. Oi, oi, oi.
Just a note, this session is being recorded, so we will upload this in the internet and please have this in mind.
Yes. Okay. So here is the outline of today's presentation. I will start with an introduction about the remote sensing, some information about the satellite data and useful tools and data provided by Copernicus, some tools for processing and analyzing the images, as well applications from Eratosthenes Center of Excellence, and the conclusions for my presentation. So, what is the remote sensing? Is the technology that helps us to acquire information about an object or the Earth's surface without actually being in contact with this. And this is done by sensing and recording the reflection or emitted energy. In general, the most common source is the sunlight. There are different ways to collect data, as Professor Gita said before. We can start from in situ measurements using in situ sensors on the Earth's surface. After that is drones. We can collect data from UAVs that contain several sensors, such as multispectral cameras, or other sensors such as the thermal cameras. We have also the airborne systems and the satellite sensors. We have two main categories of sensors. The first one is the active sensors, which have their own source of light, and this actively sends a pulse and measures the backscatter reflected to the sensor. And in general, it's the radar sensors like the Sentinel-1. We have also the passive sensor, which are measure the reflected sunlight, which are emitted on the Earth's surface from the sun, from the sun, and are the optical images. And here is a difference between the passive and active sensor. As you can see, the passive sensor it cannot penetrate the clouds, so it capture also the clouds. And in contrast, the active sensor can penetrate the clouds and retrieve the information under the clouds. And why we choose the Earth observation from satellites? The Earth observation can deliver key environmental information that support decision making. Have also globally consistent. It's a cost-effective method, And from that, the Earth observation provides non-intrusive access to remote regions. And also, we have access on historical data, so we can detection changes in the Earth from long and short-term changes. So, the Earth observation technology has provided useful information in many research areas, and especially in global climate change. And over the past few decades, the large amount of data available from scientific satellites plays an important role in Earth observation technology. And let's see some information about the satellite data. Have you ever thought about how many satellites are currently available? It's challenging to provide an exact number of images collected because there is billions, and varies depending in there is billions of collected images. And organizations like NASA and European Space Agency have extensive archives of Earth observation data, and they are continually add new data on these archives. As you can see from the past until today, every year are launched new satellites. Again, here, as you can see some examples from 2001 until today, some missions that launched in the past until 2023. And let's see some data portals which can provide the remote sensing data, which are invaluable resources for scientists, researchers, educators, and policymakers. And these portals provide access to a wide range of satellite imagery for several applications. I will present three of the most common portals. The first one is the Copernicus Data Space Ecosystem, which have access in a wide range of Earth observation data, mainly provided by Copernicus program. Also, there is the USGS Earth Explorer, which provides online search and browse display or the metadata of satellite aircrafts. And another one is the Land Process Distributed Active Archive from NASA, which provides access in several data from NASA's missions, like JEDI, MODIS, Landsat, etc. I have to highlight that these three portals are free of charge. Everybody can make just a registration and have the access to this data. And let's see some useful tools and data provided by Copernicus. The Copernicus is a European Union's Earth observation program, which is looking at our planet and its environment. It's offering information services based on satellite Earth observation and in situ data. And here are presented the six categories, the six services provided by the Copernicus program, which is the climate change, the marine monitoring, the atmosphere, land monitoring, the security and emergency management. And let's see some information for each service. For example, in Copernicus Climate, there is a toolbox which links the raw data to online computing power through the programming interface, and this helps the user to retrieving and processing data or to plotting the data and create applications. Another one is the marine. It provides free, regular, and systematic authoritative information on the state of the blue, white, and green oceans on a global and regional scale. Some information that provides this service is the combating pollution, the supporting can help us to support the bloom growth, to the marine protection or maritime safety and routing. About the Copernicus atmosphere, it provides a capacity to continuously monitoring the composition of the Earth's atmosphere and global and regional scales. Again, this platform provides us maps and data for regional air quality forecast, help us to the identification of pollutants and their source, pollen concentration levels in the atmosphere, etc. About the Copernicus land, it provides geospatial information in the field of environmental terrestrial applications. Through this service, we can retrieve land cover and land use mapping. It has also the ground motion monitoring, which measures ground displacements, including landslides and subsidence. Also, there is another service included in the Copernicus land about the priority area monitoring prone to specific environmental challenges. As well, there is a systematic monitoring of biophysical parameters such as the vegetation, the crops, the water cycle, the energy budget, and terrestrial cryosphere variables. About the Copernicus Emergency Management Service, this service provides information for disaster emergency response, as well as information on the prevention, the response, the recovery, and the preparedness. And here are some services that provide this the Copernicus Emergency, which is the on-demand mapping, which provide detailed information for selected emergency situations. Also, the exposure mapping component and early warning and monitoring. And let's see some tools for processing and analyzing the collected data. I will start with the open source software tools for image analysis. The remote sensing image analysis involves the processing, the classifying, or the interpreting images and many other processes. The QGIS, it's a common used software, is a free and open, is a free, and allow the users to create or edit to visualize and analyze and publish geospatial information. Another one application software, is the EACEA, which help us to process remote sensing data, especially from Copernicus missions, such as the Sentinel-1, the Sentinel-2, and Sentinel-3, and etc. And then Google Earth Engine, which is a cloud-based platform for scientific data analysis, and it provides ready-to-use cloud-hosted datasets and a large pool of servers. And here are some other applications, but it's not free of charge. It's commercial applications. The first one is the ArcGIS Pro. It's a full-feature professional desktop GIS application. The user can make to visualize and analyze the data, can create 2D maps and 3D scenes. Another one is the ENVI software, which help us for the image analysis and help us to extract the meaningful information from imagery. Another one software is the Eratosthenes images, which again help us to the image analysis from remote sensing data and for and also the photogrammetry, the LiDAR data, and vector analysis. And I'll continue now with some application from Eratosthenes Center of Excellence. I will start with the disaster risk reduction cluster. In this cluster, we have experts that work on the soil erosion detection, soil degradation, on forest fires, on the epidemics, flood monitoring, and disaster management, in the landslides monitoring. And I will present to you some examples. Here is a fire damage assessment in a burnt area in Cyprus. We combine several satellite data to estimate the fire damage assessment, to assess the damage. Another application is the rapid landslide mapping using multi-temporal image composites from Sentinel-1 and Sentinel-2 imagery through the Google Earth Engine. And through this study, we identified some landslides that happen in Paphos region. Another example is the comparative analysis of Sentinel-1 and PlanetScope imagery for flood mapping of Evros River in Greece. And let's see some application about the cultural heritage. Our team works on the risk assessment of cultural heritage from natural and anthropogenic hazards for the looting detection, the protection of cultural heritage, etc. And here is an example of the documentation of cultural heritage of the Church of Agios Athanasios and Kyrillos. Some examples, we combine several in situ measurements to create these models. About the marine safety and security, our team working on marine pollution monitoring to illegal immigration, ocean acidification monitoring, climate change or climate change or the irreversible destruction of marine habitats as a result of anthropogenic activities. And here are presented some of our maps that created from our center about the bathymetry, land-water line, wave groups, ship detection, oil spills, icebergs, about the Posidonia, marine spatial planning, etc. About the energy, we have also here the expert Kostas Frankos, which is working on the solar radiation forecasting for energy purposes, about the forecasting of spectrally weighted solar radiation products and the continuous monitoring of total and in ultraviolet solar radiation levels and their impact. And here are some examples. Also, in the cluster of atmosphere, our team works in the air quality and air pollution monitoring to monitor the extreme atmospheric events, dust storms and dust intrusion, the climate change monitoring. We are working also on calibration and validation activities for satellite missions. And here are some examples from our equipment in Limassol. And here an example of a study about the wildfire smoke triggers serious information using the LiDAR observation over the Eastern Mediterranean. Also, in the agriculture cluster, our team works on precision agriculture, on the carbon footprint calculations, soil quality for crop productivity, hydrological modeling, food security and food safety, and many others. And here are some examples. Also, this application is a synergy between the atmosphere and the agriculture. Using meteorological radar, we monitor the extreme precipitations events and the impact of them on yield damage. In the water cluster, our team works on the water quality monitoring, microbial risk assessment, water leak detection, hydrogeological modeling, groundwater modeling, and feasibility mapping. And here are some examples from our activities. About the land, we are working on land cover and land use changes, on urban sprawl monitoring, real estate, we monitored the heat island. We made the spatial planning, urban and regional planning, etc. And here are some examples, as Professor Gita said before, about the forest species classification in Natura regions in Cyprus. And also we have made another application on detecting and distinguishing between apicultural plants using UAV multispectral imaging. And to conclude, as you can see, the remote sensing technologies are pivotal for enhancing operational efficiency, reducing cost, and addressing environmental challenges. The Copernicus services provides invaluable Earth observation data, and that data support us to make applications for environmental monitoring. Also, the accessibility of remote sensing data through various portals, allowing entities to utilize the power of satellite data for sustainable development. And the RESENSE project encourages stakeholders to leverage these technologies. And if you are interested, we can contribute in our project. Thank you for your attention.